All right, so in this video, we're just going to go back and do a little refresher on linear functions and interpreting what different parts of the equation mean and how we can use those equations to answer some questions. So the first one here tells us that the amount of money that farmers in Massachusetts paid to maintain their crops between 1991 and 2008 is modeled by our equation. P is the amount of money and T is the year, assuming that 1991 is time 0. So we have to explain what the 3.53 and the 100 mean in terms of this scenario. So let's start with the 100. So one thing to notice is that P is in millions of dollars. So that means that the 100, since that's my y-intercept, that would represent time 0. So that represents 1991. So in 1991, farmers had to paid $100 million. Because remember, it's in it's in millions of dollars. So 100 million to maintain their crops. And then the 3.53 tells me that each year the money that they had to pay goes up 3.53 million. Goes up 3.53 million. So that's what those two things mean in the context of this scenario. All right, so we're going to go on to number 2. One thing I do want you to do is change this from 123 to 125. So in 97, there were 60 million internet users, and by January 1st, 2002, there were 125. So we're going to write an equation using X as the number of internet users in millions, Y is the number of internet users in millions, and X is the number of years. That should say years. Oh boy. Typos everywhere, aren't there? Years, not yours, since 1990. So let's go ahead and start working on finding our slope. So 1997 is 7 years since 1990. And 2002 is 12 years since 1990. So between 125 and 60, that's 65. And then 7 to 12 is 5. So 65 divided by 5 gives me a slope of 13. So I'm actually going to go ahead, since I just got the slope, and answer part B and interpret the slope in the story first. And then we'll go ahead and write our equation. So this means each year $13 million there were 13 million new, we'll say, internet users in the US. So technically this is 13 over 1. And remember, it's always y over x. So this is internet users over years. That's why I knew it was each year and 13 million. So now going to write our equation, I'm going to do y minus 60 equals 13 times x minus 7. And my goal is to get this in slope-intercept form. So I'm going to distribute the 13. So I have y minus 60 equals 13x minus 91. 7 times 10 is 70. 7 times 3 is 21. 70 and 21 added together is 91. And then I would have to add 60. Now I'm getting less negative. So this would be y equals 13x minus 31. So for part C, it's asking us about the vertical intercept, which means y, which is 0, negative 31. Now that would be negative 31 million users, which really doesn't make sense to have a negative number of internet users. So we're not going to necessarily discuss its meaning in the context of the story. We're going to talk about why it doesn't make sense for the context of the story. So this is the year, our equation represents the years since 1990. So what this is telling us is in 1990, nobody was using the internet. There was a negative number for my y-intercept. So that means nobody was using the internet in 1990. Years after this, it will make more sense, but in 1990, it doesn't make sense to talk about my y-intercept. So I'm going to use our equation to determine the number of internet users in 2000. Well, for 2000, that's 10 years after 1990. So I'm going to do y equals 13 times 10 minus 31. Well, 13 times 10 is 130. So minus 31 is going to give me 99. So that means there were 99 million users. And then use your equation to determine the number of internet users on July 1st, 2001. All right, now I got to put on my smarty pants. All of the other things were January 1st. So I was using whole numbers of years because it was the years since January 1st, 1990. But they're not saying January in this one, they're saying July. So that's 6 months later. That's half a year later. So my x value isn't going to be a whole number in this case. It's actually going to be halfway through. So 2001 is 11 years since 1990, plus I'm going to go another half of a year. So I'm going to have 13 times 11.5 minus 31. Well, 13 times 11 is 143. And half of 13 is 6.5. So that gives me 149.5. And then I'm going to subtract 31. So I have 118 million, or 118 and a half million users. So really the only one that we're not going to worry about is discussing the meaning of the y-intercept. Everything else, pretty standard, cut and dry type of question that you could get. All right, waste in a landfill in over 15 years, shown in the table below. Determine the equation of the linear function that represents this equation. So one thing that I notice is these years that they've given us are not all equal increments. So if I looked at this part of my table down here, the y values, these increments would not be the same. So it might lead my mind to think it's not a linear function. But if you look here from 1 to 4, that's 3 years. And then if we subtract 10 and 2.5, that gives us 7.5 here. Now I'm going to look for the next jump. That's 3 years. Well, to get from 6 to 9 is also 3 years. And then 22.5 minus 15 is also 7.5. These jumps, this jump is 6, this jump is 2. So I'm not going to look at these jumps here to help me, but I can see this period of 3 years gives me the same jump in the tons of waste. So I'm okay looking at this as a linear function. So our slope is going to be 7.5 divided by 3. I know it's weird for a slope, but I promise you everything's going to be okay. So talking about the slope, this means every 3 years, the tons of waste goes up 7.5. So we're going to look at this equation. Now, it doesn't tell us what form to do this in. So I'm just going to do it in point slope form. And I'm going to use the first term. And now it's asking us to determine and interpret the horizontal intercept. This would be x. And we're going to include units. So I'm going to work backwards, and I'm going to subtract 7.5 from 2.5, which is going to give me -5, 0. So that means really and truly when this landfill had 0 tons of waste was 5 years before the landfill opened. Or 5 years before they started measuring how much waste was in the landfill. So 5 years before they started tracking the tons of waste in the landfill is when the waste was 0 tons. And last but not least, after 25 years, I'm just going to replace x with 25. So, oops, y minus 2.5 equals 7.5 times 25 minus 1. Oh, this is divided by 3. So then this would be y minus 2.5 equals, let me give myself more room, 7.5 divided by 3. So 7.5 divided by 3 times 24. Oh, and my little screencast is in the way. So 24 is evenly divided by 3. So I'm going to rewrite this as y minus 2.5 equals 7.5 times 24 divided by 3, which is going to be 8. Well, 7 times 8 is 56. Half of 8 is 4. So adding 4 more to that means y minus 2.5 is 60. Adding 2.5 to the other side means it would be 62.5 tons. All right, we've got 2 more, and these are all graphs. Let me focus this a little bit better. All right, Adrienne is a hairstylist. She's paying a monthly fee to rent a station at a salon. The graph is her profits each month based on the number of haircuts she performs. So this is haircuts, and this is her profit. So if she does 21 haircuts, how much is her profit? Well, her profit would be $150. What is the slope of the line, and what does the slope represent in context of the problem? Well, I already have a point here for 21, so I'm just going to go up to the next one here. It would look like that is 1. However, my scale is not 1 for x, and my scale is not 1 for y, so I cannot put that the slope is 1. I have to check my scale here for x and y. So this would be up 50 and over 24 to 21 is 3. So our slope is 50 over 3. So she earns $50 for 3 haircuts. Oh, and it froze naturally. All right, the x-intercept here is 12, 0. So that means at 12 haircuts, she breaks even, meaning she makes no money. So that means whatever she takes in for haircuts is what she's going to give to the salon as her rental fee. So what I notice here, they're asking me about the y-intercept. I don't see that on my graph. So what I'm going to do is I'm going to make a table And I'm just going to work backwards. So 12, 9, 3, 6, 3, 0. So I'm doing the points as if I was working backwards on my graph. So at 12, I have 0. Now remember, for every 3 haircuts she's making $50, I'm going backwards, so I need to subtract 50 every time I jump down 3 haircuts. So this would be negative 50, negative 100, negative 150, negative 200. So her y-intercept is 0, negative 200. So that means her monthly fee is $200. That's how much she pays the salon to work there and rent her station. So our equation would be 50 thirds x minus 200. And she's going to perform 54 haircuts in a month. So I'm going to do 50 thirds times 54, minus 200. And remember, I can rewrite this as 50 times 54 thirds minus 200. Well, 54 divided by 3, I can do that. And that would be 18. So this is going to be 50 times 18 minus 200. Well, 50 times 10 is, 500. And then 50 times 8 is 400. 500 plus 400 is 900. Minus 200 tells me she would make $700. Woo! All right, last but not least, Bob has a really old bathtub. It's draining incredibly slowly. He's filled up his tub and then is going to let the water drain out to see how long it's going to take to drain. Graph shows the gallons of water remaining after minutes. So I'm going to label my graph so that we remember that. How many gallons of water are in Bob's tub after 6 minutes? Well, 6 is here. So that would be this point. So that would be 12 gallons. What's the slope of the line and what does it represent in context? Well, I see another point on a tick mark here. So I'm going to look at this triangle. Again, check the scale. This is 2, 4. And then these are a scale by 1. So it would be 3. So that would be negative 4 thirds. So 4 gallons take 3 minutes to drain. The x-intercept is 15, 0, and it represents in this problem when his tub is empty. So it takes 15 minutes to drain the tub. The y-intercept is 0, 20. It's this point here. That's a comma. So the tub holds 20 gallons, or it starts with 20 gallons. So our equation for Bob's tub is negative 4 thirds x plus 20.